This video is called Functions Given by Formulas. It's just a shortcut way of saying, we have this function, we have this rule for our output, or kind of like a formula if you want to think of it that way. So this first one is h of t equals 2t squared minus 3. So what we want to do is take our input, whatever that might be, inside these parentheses here. Find h of negative 2 is our first one, and we're going to plug negative 2 right in for t. This is a review of what we've done previously, and I did some of these in class for the hybrid, but I'll go through it a lot slower. Okay, so for A, find h of negative 2. I'm going to write 2 parentheses negative 2 squared minus 3. It's really important that you use those parentheses when you're putting stuff in your calculator, or better yet, just do that operation in your head. The negative 2 all squared, that means it's like negative 2 times negative 2 is going to be a positive 4. And I'm still seeing sometimes people writing that as a negative 4. So we want 2 times 4 minus 3 will be 8 minus 3 equals 5. So that's my answer there. Now this one here, B, find h of 5t. We're just going to, again, take whatever's for the input is 5t, and we are going to put that everywhere we see t. So now t becomes 5t. So 2 times 5t all squared, don't forget your parentheses again, minus 3. And then when I do this, be careful to follow your order of operations correctly. Don't go 2 times 5. Don't be tempted for that. You have to do 5t all squared. So just write the 2. And then apply your power rule. 5 squared is 25. T squared is t squared. Then in your parentheses, minus 3. Now we can distribute, or not, we're not distributing. We don't distribute over multiplication, but we're just multiplying these two numbers, 2 times 25. Be careful not to double dip. Like we wouldn't go 2 times 25 and then 2 times t squared. We don't distribute over multiplication, although we sometimes might slang say that, but it's kind of like this. If you had 2 times 3 times I don't know, like 4 or something like that, right? You wouldn't go 2 times 3 and then 2 times 4. You just, you might go 2 times the 12 is 24, or you might do it as 2 times 3 is 6 times 4 is the 24. So those would be equivalent statements. We wouldn't double dip. So just a side note there, because I still see that sometimes. So we're going to have 50 t squared minus 3. Now we have no like terms, so don't try to combine something or simplify more when you can't. But you do want to simplify as much as possible when you're asked. Or even if you're not, just go ahead and do that. You can ask if it's on a quiz or a test. I try to make a note for that, but if you're not sure, of course, ask. Okay, 1c, find 5 times h of t. So now I am going to take the number 5, put a big parenthesis there, and write my entire function, 2t squared minus 3 in the parentheses. And now this one I will distribute because it's over subtraction. So I want to do 5 times 2t squared. I'll get 10t squared. And then 5 times the negative 3 is a minus 15. And we wouldn't then go try to factor this because we're done. I mean, we would just end back where we started. So kind of think about that. For instance, 10t squared minus 15 is our final answer. No like terms to combine or anything. Okay, so D is find h of t plus 5. So t plus 5 is my input. So I want to put that entire quantity in for t. So I'm going to write 2 and then parentheses t plus 5. And then that's all squared minus 3. So remember, don't be tempted to distribute before you apply the power rule. We have to square this t plus 5 squared. And then I can start simplifying down from there. So you guys are all getting really great at this. So go ahead and try that on your own. You want to pause the video. I'm just going to go ahead and do it, but you can try it first. So I'll have 2 and then quantity t squared plus, that's going to be 10t, because remember I multiply the two terms and double it. So we'll get 10t there in the middle, and then plus 5 squared, which would be 25. So remember, when you square a binomial, you're always going to have that middle term. Mostly everyone's got that down by now. And then minus 3 at the end. Now I'm going to go ahead and distribute this 2 to every term in that trinomial. So I'll get 2t squared plus 20t plus 50 minus 3. And then lastly, just compute the 50 minus 3. 2t squared plus 20t plus 47. Again, no other like terms. We're done there, and just go ahead and box it in, and you're done. Okay, you've seen some of these in your electronic homework, but let's review them. It's based on the difference quotient, or actually average rate of change. So we have h of t plus 5 minus h of t in the numerator. So that is some, output minus the other output. And then that's going to be difference of the inputs on the bottom. So just to see where this 5 comes from, just to show you, that actually comes from t plus 5 minus t. Because if we did, just remove the parentheses, we'd have t plus 5 minus t, and then the t's literally cancel, leaving us with 5. So that's where that comes from. That's actually just the average rate of change with the denominator calculated out for you already, because the t's always will cancel. And we call that the difference quotient. Okay, so we're going to go ahead and plug these things in. So we would have t plus 5 is our input. So we're going to go ahead and we could actually reinvent the wheel and write it all up just like I did in part D, but since I already just did that, you can just use it. 2t squared plus 20t plus 47. If I hadn't, I just would have done it all out like I showed you there. And then make sure you put some good brackets around here to show, indicating this chunk, this half. And then subtract the h of t, which is our just plain function, 2t squared minus 3. But make sure you put the parentheses in. That's really important because we have to distribute that negative. And sometimes I see that sort of forgotten about. So be real clear on that. Those are two pieces that are subtracted. So we're going to need to change the signs on that second function there. And then all divided by 5. And you'll probably notice some things will whittle down and literally either just subtract off, cancel off, or reduce. And we're starting with a quadratic we have here, so it'll probably whittle down to like a linear expression there. So on this, we definitely need to distribute that negative. So I'm going to rewrite that. 2t squared plus 20t plus 47 minus 2t squared plus 3, all divided by 5. Now here's where I'm going to start crossing some things out. So 2t squared minus 2t squared, those just go to 0. The plus 47 and the plus 3 actually go to 50. So then I end up with 20t plus 50, all divided by 5. Now be careful, we do want to factor and then reduce. Don't just kind of do that bad canceling thing and slash stuff out that looks like it might go together. Be very systematic so you get in a good habit, even if this one kind of looks easy to do a shortcut way. We want to factor out the 5 in the top, and we'll have 4t plus 10 left in the numerator, in parentheses, all divided by 5. Now we can reduce the 5s, and our answer we're left with is 4t plus 10. So if I write the whole thing out again, h of t plus 5 minus h of t, you don't always have to do this, but just so you can clearly see, all divided by 5 equals 4t plus 10. Given that our original was 2t squared minus 3. Okay, so you're going to start to notice some patterns maybe with these and what they look like when you're done. So just pay attention to that. You don't need to worry about that. You won't be asked to produce that, but you might be asked questions about, like, do you notice it and things like that. Next one here is F. We have solve h of t equals -1. So solve, you've had some of these in your e-homework and the other examples, but really want to drive the point home that we're setting h of t equal to -1. We want to find the input this time. We're not plugging -1 in. That's an output. So we want to find when h of t, which is equivalent to 2t squared minus 3, equals -1. So that's how you're going to set that up. Just replace this h of t with the formula that it represents, okay? Function given by formula. And now we're going to solve for t. In order to do that, you can use the square root method or whatever method you like. You could factor it or such. So go ahead and try that yourself. Pause the video and then I'll write that out. Okay, so I have added 3 to both sides, and now I have 2t squared equals 2. Divide both sides by 2. Then I get t squared equals 1. I take the square root of both sides. Don't forget your plus and minus. And then I get t equals plus or minus 1. Just double check if that fits the domain. And since this is a quadratic function that we have to start with, 2t squared minus 3, that we don't have any problems with either of those numbers. They will both work. You really have to watch for domain issues when you have the fractions, any kind of rational, equations, functions, and also radicals. So the next one here is solve h of t equals t. That's a little different. Go ahead and see what you come up with. Try it. Just kind of carry it out. You're going to do the same thing I did here. Write your function which was 2t squared minus 3 equals t. And that should look familiar to you. We've done a lot of problems like that, but it's just a little new context. And so you're going to set equal to 0. Then this one is factorable, and solve it out. So go ahead and try that one. Okay, so here it is. I have 2t squared minus t minus 3 equals 0. Factor it to parentheses 2t minus 3 parentheses, and then another binomial, t plus 1. Set equal to 0. Solve those out. I get t equals 3/2 or t equals -1. Double check the domain. It's all good. And my answer is -1, 3/2 inside braces. Now these problems are definitely a bit trickier because we have the complex rational function here. Plugging in isn't so challenging as much as the maybe using the difference quotient down here, like letter I. So I'm going to do some of these. I don't expect that you're going to do this. This is actually from pre-calc. I just want you to kind of do the introductory type, maybe on the left-hand side. And then I'll probably put in a separate video the ones on the right-hand side, or maybe we'll talk about them in class. I'm not sure how that will go. We'll see how much time we have, but you might want to just try them, and especially if you kind of work ahead and it's going pretty easy for you, you can get a leg up into pre-calc, because they just get a little odd looking. So let g of y equals 3y all divided by y plus 4. So plugging in g of 0, you should be able to do that one just fine. Just pop that right in. 3 times 0 over 0 plus 4. I would get 0 over 4. And then make sure you do right equals 0. That is not undefined. 0 times 4 does give me 0 back. And you don't want to leave it just 0 over 4. That would be considered unsimplified. And you would be marked off for that, or marked wrong in the E homework. B, find g of a half. So then we're going to get some fractions inside the fractions here. So we have 3 times y, so y is a half, so I'm going to put a half. Now be careful writing it like that. Sometimes people want to multiply the numerator and denominator by 3. So maybe just because it's big, I don't know, but put it over 1 so that you clearly have a fraction times a fraction. And you won't make that mistake inadvertently. It's just sometimes hard to do. And then we have a half plus 4 after I sub in. Now I need to simplify. So I'm going to go ahead and multiply 3 times a half would give me 3 over 2 there. And then one quick way, I was trying to think, there's a couple of different ways we could do this. You can do 4.5 pretty quickly. Just as an aside, a half plus 4 would be 4.5, right? And then we could make that an improper fraction. 4 times 2 is 8, plus 1 is 9 over 2. I mean, you can just do that in your head. And so I'm going to write that here. You don't have to think about getting a common denominator. You could. I mean, it would just be 8 over 2, and then you'd have 9/2 either way. But however you want to look at it, just kind of compute that in your head, 9/2. Those are the kind of things you shouldn't need a calculator for. Just work on it, practice it, get fluent with that. Then we could use the technique of clearing the fractions within fractions, because I have a complex rational. So I'm going to multiply this whole fraction by 2 over 2. And when I do that, my denominators will nicely reduce out. And I will just be left with 3/9, but I'm not done yet because I can reduce that. So 1/3. Okay, next one, we're going to look at g of -4. So I'm going to plug in, I'm going to do it just underneath here, 3 times -4, all divided by -4 plus 4. And you can kind of tell that's not in the domain for a reason. We are going to get -12 divided by 0. So again, don't just leave it that way. You must write undefined, or you could write does not exist, something like that. Okay. Find g of y plus 2. So now we're plugging in an expression. Sorry about that, mate. Sometimes this just zooms funny. So we have 3 times y plus 2. I'm plugging in for y. And then all divided by y plus 2. Don't forget, because that's everywhere I see y, I have to put the input, the given input. Okay. And then plus 4. Now I'm going to simplify, and I can distribute the top, 3y plus 6, all divided by y plus 2 plus 4 would be y plus 6. Now here's where it's tempting. You're done here basically. There's not much else you can do to simplify. You could, if you wanted to, kind of go back to here and write this is 3 times y plus 2, but you just were there. That's not simplifying in this case. But what people tend to want to do, they might cross out those 6's, and they might even cross out the y's, but that will not work. Those are not equivalent things to do. You cannot reduce terms with terms, only factors with factors, numerators and denominators. So if you're ever not sure why that works, just plug some numbers in and see if that rings true when you do that. So that would be our final answer. We have E, find g of y plus 2. So sometimes when I put these on, people say, did you make a typo? No, I want you to take g of y, which is 3y over y plus 4, and put parentheses just in case you need them, but I think we're good here. And then plus 2. And can we simplify that any further? Nope, because we don't. We could maybe get a common denominator if we wanted to. A lot of times I'm just looking for this. I know I don't need the parentheses actually, but just think of this as output plus 2. Okay, so that's my function, 3y over y plus 4 plus 2. So that 3y over y plus 4 is considered my output. If you wanted to get a common denominator, you would just have to multiply the 2 by y plus 4 over y plus 4, and you could work it out that way. I can actually do that. I'll stop it and show you what that looks like. Okay, so if I did that, I would have 3y over y plus 4 plus 2 times quantity y plus 4 over y plus 4, getting a common denominator. So I can't clear the denominator. It's an expression at this point, so it's set equal to anything, not solving. And then I would distribute the 2 times y and the 2 times 4, so I would get a plus 2y plus 8 on the right hand side there. Then combine like terms, I would get 5y plus 8, all divided by y plus 4. And here's where just don't be tempted to like kind of reduce the 8 with the 4. You can't, because they're separated by, I have a plus in between here, not a parenthesis, not a multiply operation. So I can't just take that one term with this term. They're not factors. So F, we have g of 2 over y. And that one is going to plug in as such, 3 times 2 over y over, and it's normally it was y plus 4, so I'm going to put 2 over y plus 4 in the denominator. So I can use my clearing fractions technique. Remember, this 3 is like over 1. So that's equivalent here. I'm going to write that in purple. I'll have 6 over y. And then I have the 2 over y plus 4. And I'm just going to put that over 1. Now I can't combine those easily like I did above because it was just numbers. So I am going to take the entire fraction and I'm going to multiply it by the common denominator. So I look at all the denominators involved. So I have a y here and a y and a 1. That's a denominator. These are denominators, okay? So what I have as my lowest common denominator is actually the y. So I'm going to multiply by y over y. Then I'm going to, distribute basically. Okay, so I should then write that out. I'm going to carefully move this up. Hopefully it won't zoom on us. And I'm going to rewrite that as 6y times y over 1. And then 2 over y times y, I should say, over 1, plus 4 over 1 times y over 1. Now I can reduce, I can clear that y with the y. Can clear these y's reduce to 1. And this, nothing reduces, but that's okay. Then I'm left with 6 in the numerator, and that's over 1. So I'm just going to put my line. We're just trying to get back to a regular fraction. And then here I'm left with 2. And here I'm left with plus 4y. Now on this one, I can see I do have some things that I could factor out. So I'm going to go ahead and leave the 6, and I'm going to factor out a 2. And then I end up with 1 plus 2y as a binomial. Now I can reduce this 2 goes in the denominator, goes to 1, and that would be 3 in the numerator. So that's how you properly, quote unquote, cancels what it's often called, but it's really reducing. And then I'm left with 3 over 1 plus 2y as my final answer. Be careful not to just kind of randomly slash things out. Oh, I think I'll just, kind of reduce that and get. Sometimes when they both work, go in, it's fine, but a lot of people don't do that. They just do what they see goes in and leave the other one off. And it's just still not good practice to do reduce terms with terms at all. So you got to factor it, and then the 6 actually has a factor of 2 times 3. So if I wrote that like that, 2 times 3, the 2's are factors that reduce out. That's what I mean. Factors with factors are what reduce. Okay. So I do like this letter J, where I'm going to leave the G, H, I for later. we'll work more with those. But J, I like that one. That's good practice for solving and dealing with our rational equations. I'm going to rewrite it up here, though, to just give me more room so I can show you everything out. But the first step is going to be getting your g of y set equal to 3. So remember what my g of y is. Okay, so g of y is equal to 3y over y plus 4. I just rewrote that up there. So I'm going to replace the g of y with that formula. 3y over y plus 4 and set it equal to 3. Now I can use my process of clearing the denominator because I do have an equation. My key word here is solve. So I'm given the output of 3 and I want to find my input, which is y. So we can clear the denominator by multiplying by y plus 4 in parentheses on both sides. Or you can think of it as cross multiplying. That works too. Then we have 3y equals 3y plus 12. We're just going to distribute that. And then we subtract 3y from both sides. Which is kind of weird. I'm like, what's happening here? But just follow through. We get 0y, which is the same as 0. Be careful not to just put a y there. Sometimes people do that. But 3y minus 3y gives us 0. You can write 0y, but just write 0. You don't have to simplify that later. And then what happens is we get 0 equals 12. So that's a weird thing. 0 does not equal 12. So we would say this is untrue. And just like before, when we get untrue statements, therefore, there's those 3 dots in a triangle, there's no solution. And that would be your answer. Next, we're going to look at an application problem. We have the weight of a large breed of dog t years after birth can be modeled by w of t equals 10 plus 100 times parentheses 1 minus 1 all divided by 1 plus t squared and parentheses pounds. Part A says find w of 2 and explain its meaning using everyday language. Now you've done these kind of things a little bit now with the everyday language. You're used to substituting things in. We do have some fractions involved, but you can handle that. I think you can try it without a calculator, just see if you can get that down, but you can check with one. So I want you to try that. Just plug the 2 in to the function here for t and see what happens and how you would interpret that in a sentence. And then B is you're going to set the function here equal to 60 and you're going to solve just like we did a moment ago. It's going to be a little tricky one to solve, so I'll definitely come back and go through that with you. And then C is what is the growth rate from t equals 3 to t equals 6. So to set this up, we want the rate of change, right? And it's a curve. Well, this is like a rational type graph that we get, but we will be able to use our average rate of change formula. And we can, remember, we could do f of b minus f of a over b minus a. So in your case, you're going to actually find f of, well, it's really w. That's just the generic. So ours is going to be w of 6 minus w of 3 all divided by 6 minus 3. So you have to, in order to figure that out, you have to plug the 6 into the function, crunch the numbers, plug the 3 in, crunch the numbers, and subtract them. It's easier to do them separate in this case because it's kind of a big long function. Okay, so I am going back to up to A and I'm going to go through what I did. So plug in 2. Hopefully you were able to follow that part on your own. And you're going to plug 2 in for T. So I have 10 plus 100 times quantity 1 minus 1 over 1 plus 2 squared, which gives me that 1/5 over here on the right hand side. When I just subtract this, I'll get a 4/5. So now I wrote everything out, but just jumping over to describe 10 plus 100 times 4/5, that would give me, I could reduce that 100 with the 5, so I get 20 times 4, which is 80. So my answer is 90. So that's a 90-pound dog. And it's only 2 because 2 is the time in years after birth. So it's at 2 years old. The dog weighs about 90 pounds. So I used to have big Old English sheepdogs. So that's pretty big for a 2-year-old. So for part B, we'll go through that one together. Okay, so to start off with, I just wrote 60 equal to the function 10 plus 100 times parentheses 1 minus 1 over 1 plus t squared. My first step is I'm going to want to subtract 10 from both sides. So I get 50 equals 100 times this 1 minus 1 over 1 plus t squared. Then I would divide both sides by 100. So I can isolate the part with my variable in it, and I end up with a half equals 1 minus 1 over 1 plus t squared. Now I can subtract 1 from both sides, and I would get a negative a half equals negative 1 over 1 plus t squared. I can just kind of get rid of those negatives. I can multiply through by negative 1 on both sides. So I'm going to go ahead and do that. I'm just going to bring this up higher. So I would have 1/2 equals 1 over 1 plus t squared. Then I can do what's called cross multiply. So I would have 1 plus t squared equals 2. Subtract 1 from both sides. Get t squared equals 1, and by now you know that would be t equals plus or minus 1. And you have to think, is that a reasonable domain? Does 1 work in there? What's going on? So the domain would only be positive, I believe, because that would be, we wouldn't have a negative birth. Even though the negative 1 would work up here as because I'm squaring it. And so I would always end up with positive my denominator. It would make sense to have it be a negative year. So we're just going to pick the positive 1. And we would write the answer as the dog will weigh 60 pounds at 1 year old. So that's kind of interesting. My dog now, she's like 13 and a half, and she weighs about 60 pounds. So a 1 year old puppy, pretty energetic. Would be a handful at 60 pounds. So C, what is the growth rate from t equals 3 to t equals 6? So hopefully you've had a chance to work that one out. If you hadn't, pause the video and try it. This is one where I think you can definitely do on your own. I'm going to pause the video and write out how I figured out my values so you can see. I ended up for an answer, overall answer was 2.43 pounds per year is over the years 3 to 6 is what the dog gains. But I'll write out my steps. I'm not going to record everything though. Okay, so I plugged everything in. To get this 1 over 37, I just remember it was 1 over 1 plus the t squared, so 6 squared would be 36, plus that would give me 37. Then I just simplified down. I get 107.3 pounds. W of 3, same deal. I get 100 pounds. Then I plug it into my average rate of change formula that I had up above, and I get 7.3 over 3, which is about 2.43 pounds. And then I interpret that in a sentence. The dog will gain about 2.43 pounds each year on average, that's important, from ages 3 years to 6 years old. Right, thanks for watching.